Hello and welcome to section 6, Tuning's XGBoost algorithm. And in this video we'll learn how to find the best number and size of decision trees. Let's just start with explaining why this actually matters. So in gradient boosting, we keep adding those decision trees and we correct errors in those new trees, the prediction errors of the previous ones in a sequence. So there are two key hyperparameters that influence this process in XGBoost. The first one, this is the number of trees to create. By default, we have 100. And we are using the n_estimators argument when we initializing our XGB classifier to set up this hyperparameter. Then we also have the size or depth of each tree. And by default, we have the level of the tree set up as free, and this is represented as max_depth argument when we initialize in our classifier. Be clear about this, the hyperparameter is simply a argument that we pass into the classifier or regressor when we initialize in it, right? And the actual parameter in ML lingo means that those are the parameters that are learned during the training. We often, don't have any direct influence on, what they are, right? Because they are kind of discovered during the learning process. So the key question is how to find the best optimal values for those single hyperparameter or the combination of those two. So first thing that we can do, we can, keep it really simple, and we often start there, is that we can just try out some values and see if we can get an improved accuracy. And this is, of course, time consuming and also labor consuming in a way, because we have to write this piece of code and we have to kind of repeat this code. Of course, we can think about more sophisticated code to actually automate it a little bit, but in scikit-learn we've already have this functionality of automating this process of going through the ranges of values for each or choosing hyperparameter, and for each of those hyperparameters we initialize our classifier or any other model, and we verified its accuracy. So you can pretty easily, using grid search, you can look for those hyperparameters. We have to define the range of those, and then we test each value and see how our model will perform using those values. And we also can do that in a more random way using additional layer of randomness. So with grid search, we try them out in a sequence, and that has some advantages because this is a linear process. In a way, it's a sequence, it's an easy to understand process. But often in machine learning, we get really great results when we are using some kind of additional randomness. And here, with randomized grid search, we simply do the same. We look for those values, but instead of going in a sequence and looking for those values, we basically choose some kind of statistical distribution of values, and we're using those values to test our models. And for simplicity, we'll be using the grid search, and this is also the most popular, but I highly encourage you to also check out the randomized grid search and compare the search and randomized grid search, compare both of them. And you can find both inside scikit-learn. And we also can start with just testing one hyperparameter, and we can also just start with testing both hyperparameters or more. And we basically, when we testing more than one hyperparameter, we basically testing the combination of those two. In our case, our dataset is pretty small, so we pretty much can start with testing only hyperparameters. But keep in mind that the bigger the data is and the more parameters we need to check, the slower the search will be, right? Obviously, because we have to initialize our model with each of those values, and those, the more parameters you have, the more combinations you will have. And also keep in mind that each test is basically the cross-validation test, so this is also pretty time-consuming. When you don't know where to start, just start with some small experiments, small ranges of values, and ideally you can start with just one hyperparameter and left the other hyperparameters alone, then test it out, and then progressively see which values come up, and then try to do, combination of more than one hyperparameter. There are many ways of going about it, and it's really, you have to experiment a little bit and see what will be, the best solution for you. So let's see how this grid search works in terms of looking for the best number and size of decision trees. So let's open a terminal and go to the source directory for this section. In my case, this is desktop, Boost in Python, section 6, source. And let's open a new Jupyter notebook. Let's create a new Python free notebook. And we can rename it as usual S6 for section 6, then S video 1, V1, and then you can call it tuning trees. And we started with importing our get data function, where we've put all of the functionality to get and convert and prepare the data so we can use it with our models. So let's do that now. So from BP section 1 video 5 data, import get data, and then we have to import the cross-validation functionality. But in our case, this is really this grid search functionality, and inside this grid search functionality, we also have cross-validation as well. So we will again use the model selection package, and inside of them you can find grid search CV, and this is what we'll be doing here. And I've mentioned that you can try the random grid search CV, and this is located in the same package, also in model selection. So let's import model selection from sklearn, import model selection. And we also have to provide the actual model to test or to search values for. And this will be our XGB classifier. So let's import that. So from XGBoost, import XGB classifier. Okay. And we also need to set up our number generator seed. This is a fixed number that we use to reproduce results every time we run those examples. So just to keep in mind that we use that value to initialize our classifier. Sometimes we use it for some other functionality, basically to make sure that we can get the same results every time we run this code. Okay, let's get the data. We are using a get data function to do that, and we simply run it with the path to our CSV file. Okay, and next step, let's initialize our classifier. And again, this is what we've already done many times. We simply use our seed as a initializer for the random number generator for this classifier. So we basically get the same results every time we run this code. Okay, let's run that. Okay, now we have to define the ranges of values for a specific hyperparameter that we want to test. We want to start with number of trees, and it's up to you to actually define those ranges. There are some, the more you're actually using XGB classifier and random boosting algorithm, you'll see which values make sense. But let's assume at this point that we don't have this knowledge. We're just starting out, want to test out some values. So we can start with number of trees 50 and let's test it to 500, progress it by 50 again. So this is the range that we'll be testing from 50 trees to 500 trees, and we'll increase every 50. And then again, the more values you will have here, the slower the actual grid search will be. So you have to be aware of that. Start small. Okay, let's now test the size of the trees. And let's just start from 1 to... Okay, so the next step is to create a dictionary that will map those values, those ranges into the actual arguments for a classifier. So params to search will be a dictionary, and let's just name those arguments appropriately. And estimators, this is the number of trees, and max depth, the name of the argument is exactly the same as this variable. Okay, so those are actually names that we are using inside the grid search to initialize our classifier. Okay, looks good. Now we have to initialize our grid search. So let's do that. So this is our grid search. And inside model selection, we have grid search CV, cross-validation. We have to first specify the model we want to test or want to search. This is our C, our classifier, then params to search. So we will be testing this classifier with the specified ranges of values for each hyperparameter. Then we also choose the method to judge if a given set of hyperparameters perform well or not, or we can compare those results to each other. And this is where we need the loss function. So we need to choose that using scoring argument. And we have a couple of options here. We can use by default for classification. I think this is the actual accuracy metric. But the problem with accuracy metric is that it actually gets biased when you have uneven number of classes in your dataset. So we'll use a bit more universal loss function for classification, which is called cross entropy. And I won't go into details why it's negative. This is the way that this grid search functionality actually works. And the thing that we have to keep in mind is that the smallest possible loss value means that this set of parameters is the best amongst the other. But, I'll give you some examples, the output of this process, so we'll see for yourself. Okay, so we have our loss function here. We can also say how many parallel computations do we want to perform, and n_jobs will help us to, when we set up to -1, it means that we basically want to use all of the available resources. We also have to specify what kind of cross-validation we want to use, and so far we've used 10-fold cross-validation, so let's set cross-validation to 10. And the last argument will disappear in future releases of scikit-learn. We have to set it to false. This is the default kind of a behavior of the grid search, so let's keep it at that. Okay, so we've got our grid search defined. Run it. We simply run fit on that for our x and y. And it will take a bit to actually look for those or test those ranges for each hyperparameter, also the combination of those parameters. But when it finishes, I forgot to actually add a output value here. So let's do that. Try again. So I've added the actual variable that will get us results, and we'll be able to examine those results of this grid search. And previously that would just, we won't be able to examine the results of this grid search. And when it finishes, we will be able to see the best hyperparameters combination that we can get. Okay, so it's done. You can see that there's no longer a star here. So let's check what it actually find out. So grid results has a couple of values or keys here that we can examine, or to be specific, attributes. So when we want to look for the best parameters that the grid search found, we can just have a look at grid results and best underscore params underscore. So this will show us the actual parameters that got the best results, or the smallest value for our loss function, right? Because the goal of each loss function is to get the lowest value, and this is what we've got with neglog loss. But leaving that behind, this shows us the best hyperparameters combination of those hyperparameters that we've got. And we can also have a look at the exact values that we've got here, and the values for each combination of those hyperparameters are kept in grid results, CV results underscore. And we have a couple of values here. Let's first have a look at mean test score. So those are actually the output of our loss function that for each of combination of those parameters, we get those values. And the smaller the value, the better. So the smallest value, this is the best possible combination. And to make it more concrete, we can just have a look at those parameters. So this array is exactly, those indexes from this array, or those values from this array, matches those parameters. So each of those parameters gets tested, and we get the value of neglog loss. We can find those particular arguments. So we've got it 0, 1, 2, 3, 0, 1, 2, 3. And we can see that this is smallest, the output of our loss function, right? So this is how it goes. You can even plot that and see how this, which values are close and which are a bit further from each other. But what we really, interested in at the beginning is to get these best params. And once we've got these best params, we can use the cross-validation again with those parameters to actually see results. So see the actual accuracy. And I leave it to you to actually do that for yourself, because we've done it many, many times before. And just keep in mind that you have to use those arguments as an initializer to a classifier.